SpaceX has finally revealed its new and improved Falcon Heavy rocket. The Falcon Heavy forms the backbone of the company's fleet of launch vehicles and is currently responsible for launching satellites into space for the government. Let's take a closer look. The Falcon Heavy is a large cargo lifting rocket developed by SpaceX. When it launched on its maiden voyage on February 6, 2018, the rocket was the most powerful booster in operation at that time. On that debut test flight, the Falcon Heavy met almost all of its major objectives, including flying company founder and CEO Elon Musk's Tesla Roadster, carrying a mannequin named Starman to space. Over the years, more flights have been planned for the rocket as the company begins to seek out more customers for Falcon Heavy. Eventually, Elon Musk plans to use the experience of developing the Falcon Heavy to make an even bigger rocket, named the Big Falcon rocket, for Mars exploration. SpaceX was founded in 2002 and backed by Musk, who previously co-created and sold the companies Zip2 and PayPal. After successfully developing and flying the Falcon 1 rocket, SpaceX received funding from NASA to develop a spacecraft, the Dragon capsule, that, in 2012, became the first commercial spacecraft to bring cargo to the International Space Station. To get to space, the Dragon required a heavier lift rocket called the Falcon 9, which SpaceX developed and then first flew in 2010. Musk first announced a bigger rocket, the Falcon Heavy, in 2011. At the time, he said the rocket would carry 117,000 pounds of cargo to orbit, twice the capacity of the Space Shuttle. Musk also predicted the first Falcon Heavy flight would come in 2013. As is common with spaceflight, however, that date was pushed back several years during development. There were two catastrophic failures of the Falcon 9 rocket in 2015 and 2016. Flights were suspended both times while the cause of the failures was investigated, and that likely contributed to pushing back the timeline of Falcon Heavy. SpaceX completed a static fire test of the Falcon Heavy center core in May 2017. By September of that year, all three boosters planned for the first flight completed static testing. According to SpaceX, the Falcon Heavy is 230 feet tall and can lift nearly 141,000 pounds of payload to low Earth orbit, about twice the payload capacity of its closest competitor, United Launch Alliance's Delta IV Heavy. The rocket has two stages. The first stage is 3 engine cores. The center core is flanked and supported by 2 boosters. Each core is equivalent to the first stage of a Falcon 9 rocket and houses 9 engines. The boosters separate after liftoff and land upright back on Earth, possibly to be used again. Meanwhile, the heavier center core aims for a drone ship carrying its payload in the second stage. The 27 engines on the first stage of Falcon Heavy, working together, are capable of more than 5 million pounds of thrust at liftoff, the same force as about 18 747 aircraft at full power. The Falcon Heavy rocket lifted off for the first time on February 6, 2018 from Kennedy Space Center in Cape Canaveral, Florida, using Launch Complex 39A, the pad that used to host moon-bound Apollo astronauts and space shuttle crews. An estimated 100,000 spectators crowded the area's beaches and roadways to watch the rocket launch. Millions more watched a live stream showing the launch and events afterward. During the launch, 2 boosters separated from Falcon Heavy and landed at SpaceX landing sites at Cape Canaveral Air Force Station near KSC. In the coming years, SpaceX plans to develop the Big Falcon rocket, a system that would dwarf the Falcon Heavy. According to Musk, BFR could be used to bring hundreds of passengers at a time to different destinations around the world and onto Mars. In September 2017, Musk delivered an updated version of his ongoing Mars colonization plans that would include the use of the BFR. Musk has said that the BFR will likely replace the Falcon Heavy and Falcon 9 rockets during the 2020s. The Raptor engine forms the core of every rocket in use at SpaceX. With this in mind, the company has decided to give the engine a much-needed upgrade to improve its performance. In recent months, SpaceX has used 2 variants of the engine, with the newer one dubbed Raptor 2. The company states Raptor 2 includes a large number of performance and reliability improvements over the previous iteration. The Raptor engine is a full-flow staged combustion cycle engine that runs on super-chilled liquid oxygen and super-chilled liquid methane, both of which will power SpaceX's next-generation vehicle, Starship. The Raptor engine benefits from the highly advantageous FFSCC cycle, maximizing the impulse generated by a given amount of propellant. It is the third FFSCC engine to ever be developed and the first to leave the test stand. The first stage of Starship, called Super Heavy, will be jam-packed with 33 Raptor engines, 20 non-gimbaling Raptor engines in the outermost ring, 10 gimbaling engines in the middle ring, and 3 gimbaling central engines in the innermost ring. This number is expected to decrease in the future as SpaceX further upgrades Raptor. The second stage, Starship, currently hosts 6 total engines, 3 vacuum-optimized non-gimbaling engines and 3 sea-level gimbaling engines. Elon Musk has noted that in the future the ship is likely to gain 3 more vacuum-optimized engines once they increase the length of the ship. Raptor is constructed from SpaceX's proprietary SX500 alloy, copper, aluminum, and steel alloys. There is no information to suggest that these have significantly changed between Raptor 1 and Raptor 2. The engine relies on a small amount of 3D printing. However, SpaceX is trying to remove as much 3D printing as possible due to the inability to scale, high cost, and low manufacturing rate. One of Raptor's most impressive specs is its gimbaling range. The engine can gimbal 15 degrees on the Y and Z axes, which is needed for the flip and burn landing that Starship does. A gimbal range of 15 degrees is a lot. For comparison, the RS-25 gimbals to 12.5 degrees, and the SpaceX Merlin engine gimbals to 5 degrees on the first stage. At the beginning of 2022, the first Raptor 2 was spotted, marking the end of Raptor 1. After Raptor 2 production began, SpaceX stopped producing all Raptor 1.5 engines. Compared to the original Raptor, Raptor 2 looks borderline incomplete. A large amount of plumbing and sensors have been removed, transitioning the engine from a Christmas tree look to a significantly cleaner look. On the original version of Raptor, while SpaceX was learning how to control the engine, a very large amount of development sensors were needed, allowing them to track pressure and temperature throughout Raptor's plumbing. Additionally, many valves were combined into valve plates, helping further simplify plumbing. By removing a large amount of these components, SpaceX has made the engine more flame and heat-proof, a clear step towards SpaceX's goal of removing all engine shrouding from the booster, which would decrease the booster's mass by 6 tons. This is a clear example of Musk's "the best part is no part" mantra. SpaceX has recently revealed an updated version of the Falcon Heavy rocket. The rocket has already made history by launching and landing as the first reusable rocket, but SpaceX is always looking for ways to improve and innovate. One major focus of the upgrade is increasing the rocket's payload capacity, allowing it to transport more cargo or humans into space at a time. Another area of improvement is in the rocket's propulsion system. SpaceX is experimenting with using advanced engines and fuels, such as methane and oxygen, to increase the rocket's power and efficiency. The upgraded rocket will also feature a sleek new design with a streamlined shape and advanced heat shielding to withstand the intense temperatures of re-entry into the Earth's atmosphere. In addition to these technical improvements, SpaceX is also working on making the rocket more cost-effective to produce and operate. The company has a strong focus on sustainability and is exploring ways to reuse as many parts of the rocket as possible to reduce waste and to lower costs. The upgraded rocket is expected to have a longer lifespan and be able to fly more missions before needing major maintenance or repairs. These improvements will not only benefit SpaceX, but also the wider space industry and humanity. With a more powerful and efficient rocket, SpaceX will be able to access new destinations in space, potentially opening the possibility of establishing a permanent human presence on other planets. One of the key benefits of the upgraded rocket is its increased payload capacity, which will allow it to transport more cargo or humans into space at a time. This will be particularly useful for missions to the International Space Station, where the ability to deliver more supplies or crew members in a single launch will greatly improve efficiency and reduce costs. The upgraded rocket will also have the capability to fly a wider range of missions, from satellite launches and cargo deliveries to human spaceflight and interplanetary travel. This versatility will make it a valuable asset for a variety of customers, including government agencies and private companies. In addition to its technical advancements, the upgraded rocket will also feature new safety features to ensure the safety of the crew and cargo on board. This includes upgraded systems for communication, navigation, and emergency response, as well as improved reliability and redundancy to reduce the risk of failure. According to some reports, the company is targeting no earlier than January 12 for the 5th launch of Falcon Heavy. As was the case for the rocket's third and fourth launches, the main customer behind its fifth launch is the U.S. military. Deemed USSF-67, the mission's also expected to be very similar to Falcon Heavy's most recent launch, USSF-44. That mission saw the massive SpaceX rocket complete its first direct launch to a geosynchronous orbit 22,250 miles above Earth's surface, where it deployed a pair of spacecraft carrying several rideshare payloads and satellites. Save for the possibility that the U.S. Space Force includes secret payloads on USSF-44, the mission appeared to be more of a rocket test and loose collection of experiments than a major military launch. The mission will be Falcon Heavy's second launch since June 2019 and is scheduled to lift off 72 days after the rocket's USSF-44 launch, which finally ended its unplanned 1,225-day hiatus. The schedule is reminiscent of 2019 when SpaceX launched its second and third Falcon Heavy rockets 75 days apart. If you like this video, you may also enjoy this one, which talks about the first ever signals coming from Proxima b. Do you think the new Falcon Heavy will be ready this year? Please share your thoughts in the comments section below.